welcome to another video on Norton's theorem. The goal is to find the Norton equivalent of this circuit, and to do that we need to find the Norton current and the equivalent resistance when all the independent power sources are turned off. And to find the Norton's current, however, all we just have to do is to connect a current source across terminal A and B, and the current that would flow in this direction, that will flow through this short circuit, would be I of n, which is the current source in the equivalent Norton circuit. And to find that, we can simply use nodal analysis. If we do use nodal analysis, we have one essential node here, let's call 1, another one here, 2, and a third one which we can make our reference node. And you see that since this node is shorted with ground, we can say that V2 is equals to 0 volts. In short, node voltage at this node is 0 volts. And you can see that these two nodes, this node is it has a 24 volt power source in between it and the reference node, so we know that V1 is equals to 24 volts. So we know the value of V2 and V1. So we know the value of V1 and V2. We will now proceed to find the value of IN. We will proceed to write a KCL equation as node 2 using node voltages. So that will look something like this. We say at node 2, V2 minus V1 over 2 plus 4 plus V2 over 8 plus 3ix, so we have 1, 2, 3, 4, and then plus in equals 0. We should pay attention to the fact that ix is equals to V2 over 8, and since V2 is 0, all of this will be equals to 0. So that means this term and this term are equals to 0. So you can say V2 minus V1 over 2 plus 4 plus in equals 0. We got rid of this and this, and we have minus 24 over 2 plus 4 equal plus in equals 0. So that will be minus 12. So in is equals to 8 amperes. So, and flows in this direction. Then the next thing we want to find is R of n. So basically what we're going to do is we're going to put up these two independent power sources, and we're going to connect a 1 volt power source and calculate the current that it supplies, then take the inverse of that. The inverse of that will be the value of R of n. The circuit to calculate R of n will look like this. We have to connect a 1 volt test source across here, so here. Then we can use mesh analysis to calculate the current. If we call this mesh 1, and we call this one mesh 2, I'll call this one mesh 3, and just in finding this current. So that, which is the current of mesh 1. So we know that 1 minus 2, I1 minus I2 is equals to Ix, and we know that the current here, I3 is 3Ix. I3 is 3Ix. Okay, then we can proceed to write an equation, a KVL equation in this loop, where we can say that I2 minus I3, I2 minus I3 multiplied by 2 plus, okay, that will be minus Ix, because it's opposing the direction of the current flow, minus 8Ix equals 0. If we substitute this here, we would have 2I2 minus 6Ix minus 8Ix equals 0. So we have 2I2 minus 14Ix equals 0. Okay, we can solve this equation and this equation. Okay, we need a third equation. For our third equation, we can get our third equation here. That would be 8Ix equals 1. So that means Ix is equals to 1 over 8. If we know that Ix is equals to 1 over 8, using this equation here, we can say that I2 is equals to 7 over 8. 7 over 8. And we can then use that here in this equation here, this one, and we will arrive at I1 to be equals to 1. So the current here is 1 ampere. So the inverse of 1 ampere, R of N, is 1 over 1, which is equals to 1 ohm. This we can draw the Norton equivalent circuit, which will look something like this. And we have A, B, and the current will flow like this, so that we'll be able to come down, just like with I of N, it will come like this. So we have 1 ohm, and then we have 8 amperes, and we have our terminals A and B. That will be all for today. Thank you for watching. Don't forget to hit the like button and subscribe. See you next time. Bye.